Hello my dear students, in this lecture we will talk about moment of inertia, very interesting concept of moment of inertia. Okay, so I is the moment of inertia, moment of inertia. Okay, how we can define moment of inertia? It is the moment of mass. Okay, it is the moment of mass. So what is meaning of moment of mass? Let us consider a body of mass m. First we are talking about the point mass. For the point mass, for the particle. Okay, what is moment of mass? It is m into r, mass into its distance, perpendicular distance from the axis of rotation. Moment of mass, and moment of mass, again we have to take moment of these, it will give us I. So for any point mass, for any particle, the moment of inertia is mr square. The moment of inertia is mr square. Now if you talk about the distributed system, so what is meaning of distributed system? First we have to understand, it is the combination of point masses. Okay, combination of point masses. Okay, so if let us consider all the planets, we are considering all the planets are point masses, because the distance from the sun of all planets are very large as compared to the radius of the planet. So we can consider as a point if we are talking about the solar system. Now you know very well, we having 8 planets. So it is the combination of 8 planets. Okay, 8 point mass. So in this case we have to take, what we have to take? We have to take moment of inertia of each. So what you can do to find the moment of inertia of each? We can do the summation, I equal to 1 to n mi ri square. Okay, moment of inertia of each particle. But what you have to do, what we have to do to find the moment of inertia of a rigid body? So what is meaning of rigid body? The third case, rigid body. Third case is rigid body. So how we can find the moment of inertia of rigid body? To find the moment of inertia of rigid body, we have to take integration. We have to use integration. At the place of summation, we have to use integration. Okay, of r square with respect to mass. Okay, so let us consider this is a rigid body. Now we are considering a differential mass dm, which is a distance r. Now we have to integrate this differential mass all over the volume. So we can find the moment of inertia of rigid body very easily. Okay, it is a concept, this formula we can use. Okay, like if you want to find the moment of inertia of this pen, of a rod, then you can consider a differential part and integrate over the volume, over the length. What you have to do to find the moment of inertia of circular ring? So whenever we talk about the moment of inertia of rigid body, some point we have to remember. Okay, first point, we have to use integration. We have to use integration. We have to consider a differential part and we have to integrate this differential part over the volume. Okay, it is the first concept. Now if we are talking about the moment of inertia, the axis of rotation is very important. About which axis you are finding the moment of inertia? If you are changing the axis of rotation, the moment of inertia will be different. Okay, so about which axis actually your body is rotating, this axis you have to remember. Okay, so all this concept of moment of inertia you have to use, you have to remember this formula whenever you want to, you are finding the moment of inertia of point mass. It is I is equal to mr square. For distributed system you have to use summation. For rigid body, okay, for continuous system or rigid body you have to use integration. Okay, so one by one in next some lectures, one by one we will find the moment of inertia of different bodies, like moment of inertia of a rod, moment of inertia of circular ring, moment of inertia of cylindrical cone, moment of inertia of spherical solid sphere, spherical shell. Okay, all this body, for all this body we will find the moment of inertia. Okay, moment of inertia of rod. So what is the moment of inertia of rod? Moment of inertia of rod. What we have to do? Let us consider a rod having length L. Okay, the length of rod is capital L and mass is m, and we have to find the moment of inertia of a rod about the axis which is passing through the center of mass of the rod and perpendicular to its length. It is the axis passing through center of mass of a rod, midpoint of rod, and perpendicular to the length of rod. Okay, so what we have to do? We have to consider a differential length, differential part. Okay, so we are considering a differential part having thickness dx. Okay, having thickness dx at distance x, So consider differential part dx at x. Okay, what we are doing? We are considering a differential part of thickness dx at distance x. So we have to find the differential mass. So what is the differential mass? Differential mass dm is equal to, how we can find differential mass? By finding the mass per unit length. So mass per unit length, capital M by total length L, total mass divided by total length into differential length. It is the differential mass. Very easily, because mass is uniformly distributed over the length. So m by L into dx, it is the m by L into dx, it is the differential mass. Now what is the formula? What is the formula for the moment of inertia? I is equal to integration r square, but in this case we have to use x square. It is the perpendicular distance of differential mass from the axis of rotation. In this case it is x. So x square into dm. Now we are putting the value of dm, which is mass by total length L into dx. What should be the limit of integration? It should be minus L by 2 to L by 2. We have to integrate from this end to this end. So x having value minus L by 2 at this end A, and at this end B, x equal to plus L by 2. So we have to integrate from minus L by 2 to L by 2. Now this m by L is constant. So we have to integrate from minus L by 2 to L by 2 of x square with respect to x. So it is I is equal to m by L, it is x square. What is the integration of x square? You know very well, it is x square by 2. Oh, it is x cube by 3. Sorry, it is x cube by 3, and limit from minus L by 2 to L by 2. So it will be m by 3L. Now we are putting upper limit, it is L by 2 whole cube minus L by 2 whole cube. Okay. So, what we have to do with this negative sign? It will make plus. Okay. So, I is equal to m divided by 3L. Now, it is L cube by 8 plus L cube by 8. Okay. Okay. So, m divided by 3L into L cube by 4. So, ultimate we will find 12 in numerator. ml square by 12. So, the moment of inertia of rod about axis which is passing through the center and perpendicular to the length of the rod, it is the ml square by 12. Now we can take another case in which we are finding the moment of inertia of the rod about one end. Rod is rotating like that. Then what we have to do? Let us see. So, it is our rod now and is axis of rotation. This whole rod is rotating about one end A and it is B. Okay. So, it is axis passing through one end, and perpendicular to its length. So, this integration I is equal to m by L, again we can consider a differential part dx at distance x, but in this case we have to integrate from 0 to L, from x equal to 0 to x equal to L. It is very easy. Clearly we can understand from 0 to L of x square dx. So, it is m by L cube by 3. Okay, we will get. So, finally I is equal to 1 by 3 ml square. I is equal to 1 by 3 ml square. Very easily we can understand. So, if you are finding the moment of inertia about the center, it is ml square by 12, and if you are finding the moment of inertia about one end, it is 1 by 3 ml square. Very easy. Thank you very much.